recording you.
Okay.
Yeah, right.
Yeah. So is everyone happy? Just to because just to record this for prosperity. Is everyone? So yeah.
What are you doing, recording?
Yeah, you're just supposed to send it to his mum and dad.
Oh, right.
Yeah.
Just be
And yeah, no problem. And yeah. And this is the. It's just asked that if I can record him. So is that okay? Yeah. Thanks. Thank you. Structure are correct. That's the thing. So that's the verification process is going. And so if you can't verify, for example, we have built a Java built a code with the Java 11, and our system support 8, and there will be structural error. So verify exception will be thrown, and these are error example. So if the verification fails, it will throw a verify error or linkage fail. If you say throw a linkage error, so the exception and difference between exception and error mean it's a critical failure. Exception can be catched and handled. If it is critical, we will get verify error, otherwise verify exception. And next one is prepare. Here we are going for the preparation of the class. So basic initialization will be done here with static fields, not the instantiation. So here you can see this for example, this variable private static final boolean enable equal true, but in this process, in this stage, its enable is equal to false. That's the default value. So static variables will be initially assigned to the default values in this stage, and then it will go to resolve. In the compilation, if you are writing a compiler, we have symbolic references, something like method names and class names. So these are stored in runtime constant pool. So these names are constant. So they are checking these, they're accessing the field, and these constants are correct. So here A, the constant of the class A should be correct, and the references. And here again, if something is changed in the middle, they can go incompatible. Yeah, these errors, incompatible class change error or linkage error in this stage also. And then we go for initialization of a class, or interface consists of executing its class, so interface in the initialization method. Now we got previously our variable is assigned to false. In this stage, it will be assigned to true, and static block will be executed. So that's why static variables and static blocks are executed before initialization of the objects and other things. So so now this will be changed to true. Then again, after the failure no class definition found, error can be thrown, and exception initialization error can be thrown. And now we are moving into after loading, we need to go to the memory. Here RAM and the PC registers are there, and so this is runtime data areas. This is used during the execution of the program. So the previous discussion also, this is the heap memory. Heap is used for basically object creation, dynamic object creation, and this is non-heap memory, and code hash. And here the true from Eden is for the newly created objects, and you can see this. You can change these values. This is fixed value, and we can have a swapped memory for the dynamically created objects. This is these values can be triggered, new size, and these are the young generation, old generation. I have to check the meaning of these things. So this is non-heap memory for the static storage, like stack frames.
Sorry, just to interrupt, because we just started a little bit late, so I just wanted to double check that if anyone wants to ask any questions about anything,
Anytime. Stop.
Or anything, anyone want to discuss anything, or if we're happy to carry on with the
Conference format.
if we're happy to carry on, we can.
Anytime, stop me.
Yeah.
And I might tell lies sometimes. Correct me. And I'm really lying.
So like this is when the programs get executed.
Yeah, it's this architectural thing. So it's still down is loaded, and now we are telling these are the areas. This runtime data access area is interact with class loader subsystem, execution engine, and native method, kind of similar.
So like because it's kind of I remember before we were talking a bit about the instrumenting code. So like checking what the memory execution is and like objects being created.
Yeah, that's right. This is the memory diagram of the. This is with the variables. These are the instrumentation of the JVM. So you can change these things here with the memory, and this is the structure of how it works. JMAC and
thank you. My eyesight is terrible.
Oh.
Yeah.
Otherwise,
Just like
if you take a document history with this graphic, one picture.
GMS and GMX.
This is the initial size. This is such size is allocated like virtual memory in the OS, so it can be expanded up to GMX maximum size.
So this is like the general architecture for Java Java 21. It doesn't matter the version.
This is the same architecture. They didn't change the architecture.
Didn't change.
As I know, they didn't come up with the new things. Same thing is going on.
Okay.
As I know, I never saw any different description.
Oh.
So we can pass the parameters like this, dash x and x here the previously XMS. So here XMS, and then XMX here. We put two different values starting. This value is already there, then maximum up to 2048 MB. And the method area. So if you take the actual assembly code, method is a one segment of instructions. It's not linked with the object, or it's kind of different implementation. Here the methods are. Method informations are in this area, the names of the method and fields and other data. So here runtime constant pool and other codes are there. And these fields, for example, it's going with here this way.
I think the feeling that garbage collection change with higher Java version. Some feeling that it's no longer used. Or it's like part of the system. It's doing in the background all the garbage collection.
The mechanism is changing for garbage collection, definitely.
No, but I never use it. I mean, I know in Java 5 and 6 I also do garbage collection all that, like, but now it's like just automatic now.
Mm-hmm.
Yeah. Okay. Yeah. The mechanism change. Yeah. Okay.
For as I remember, it was automatic, but
I remember.
We can force it. Just
You
only
were telling to give a hint
Yeah, hint.
to do it, but there was no
otherwise
guarantee.
program will be crashed.
There was different
And,
garbage collection before Java 8, if I remember. By default, I don't remember what it had, but after 9, by default you have GC called G1, if I remember. So that would go in Java 17, 21, whatever. By default you have slightly different garbage collection than, for example, in Java 5.
I also explain how little bit it works. They might change how it works sometimes. So as usually we get out of memory error in this area. If the and now we come to heap space as we saw in the previous diagram from 2 and Eden and other spaces are there. Heap shared among all all the class instances and the arrays objects. And here new employee, when you hear new employee, that instance is there in the heap. That's why we talk most of the time we talk about heap thing. This is the dynamic. As long as we create when we create more objects, heap is getting filled. And as usually we get out of memory error if we don't have enough heap memory. And now we come to stack area. Stack is Java can run multiple threads, and so it's create the one stack frame likewise, and these partial results and with the thread are stored in that.
Just
stack
to
area.
bring it back to we've got about 5 minutes, so there's a bit of a delay at the start because we're trying to get the slides and everything. So just conscious there's more sessions planned, so we've got about 5 minutes and then there'll be 10 minutes before the next session starts. But so if we want to however you want to do it, or if we just want to talk about what we've discussed so far, maybe if people are interested you can like share the slides or afterwards. So just conscious I want to give people a break as well before the next session.
I'll
So
quickly go through it.
Yeah.
So here the how stack frame works with the method calculations. Don't worry about that one much. And this is the stack memory area, how things are stored with the and this is local variables, how local variables are stored in the thread in Java. And this is the, as you know, example. And this is operand stack. Here you can see the return values can be there in the operand stack when we're returning there, and we can push and pop values. Here the machine are called these bytecode instructions, and this is frame data. Catch instructions are stored in the frame data also, and this is each thread has a programming counter. That's why one by one is increasing. That's why it's going to thread 1, then move thread 2 likewise. And so this is C++ code for the managed program counter. So if this function is assigned to 0, so it will be error. And this is a native method stack. And here stack is calling native method. Native method is calling stack back. That's how native method works. And here we are loading this C++ library, and we call it native. And here the class library name and the method name, and this is how it works. And this is the environment. This is the normal typical this variable for the header file, and this will be print likewise. So native, and this is called this method here, and it's called print this. As usual, we get these errors, and
So yeah, we probably want to wrap it up in the next couple of minutes. But yeah, I've put a lot of work in. So if people want to get the slides, I'm sure you can share the slides. So yeah.
And next person will describe about the just-in-time compiler and interpreter and
Yeah, I think
and equations.
yeah, the one not the next one, but the one after that in here. I think Swapnil's going to talk about the yeah. Yeah, half free, yeah, half free, yeah. I put it in 2. It seemed to go off halfway through.
Oh,
But yeah, I got it in 2.
you can with the full
Oh right. Yeah, sure, yeah.
Sorry, question was the thing is even Java is running with the previously here if this is true, then it's go to here. Here it's optimized. You are directly returned. So they are not wasting jump instruction to go there and there. It's directly here. So it's part of optimization. So we can avoid. So same method is calling every time. The interpret is reading again and again. We can with the just-in-time compilation, we can avoid these things. And this is a machine instruction to convert the intermediate code to. This is some assembly instruction comparison and jump. So that's the way it's executed. Computer execute machine instruction. So this is assembly. Direct machine instruction. It should be converted like that. And so this is profile. We are finding hotspots. And for like here, for example, we are adding sum. So in the main memory is there. Go to the sum main memory. Add one again. Go to the main memory. We don't have to do it. Here with the profile, it's find the hotspot and it put it to the programming register. So it will be done within the processor with the registers. It doesn't have to every time go to the sum and main memory. It take more time and resources. So in the end, the result will be stored in the main memory. So intermediate steps can be avoided. So that's the one job of the profiler. This is I already explained the garbage collection and here the out of memory error. It's famous errors. So approximately 98 of its time doing the garbage collection, and if it is recovering less than 2% of the heap, then it will throw our memory out of error. That's the condition. Doing so far at least 5. So that's the main idea of what is out of memory. It's not these are the constraints. So that's how we detect something going out with the garbage collections. And these are, I already explained this. Native methods calling. Same way as here, calling the library and say hello, and it will print hello. And yeah, this is library, how to use library. Step 1 is you have to convert to Java JMAC string into C string, that is string used in C, and performing that operation. This is print function, doing something, and from the user to string, use input something and convert it back to JNR readable form to the environment and return it. So that's a kind of framework how to take the value, do something with C, and push it back to JVM. So that's the these are kind of how more like a API or framework. So these are the errors. So I basically covered it. So more questions?
Yeah, I think the other sessions are going on, so the next session probably will start a little bit late. But yeah,
Thank you
but
very much,
feel free.
for listening.
But yeah.